code mandates a disconnecting means for motor controllers, typically a switch or circuit breaker that interrupts power to both the motor and the starter. The prevailing interpretation necessitates power removal from the entire controller. This is often achieved through an auxiliary switch on the disconnect or by powering the coil from a transformer. However, variable frequency drives, or VFDs, present a specific scenario. The disconnect for a VFD generally removes line power, but the control side power may remain active. The National Electrical Code, or NEC, does offer an exception tailored for VFD installations. The code permits the control power to be sourced separately, assuming that this separate source is both identified and approved for use in conjunction with the VFD. This allowance is rooted in the operational needs of VFD, which frequently demand an independent control power source to function correctly. Consequently, it isn't a code violation to implement a disconnect that only cuts off line power to a VFD, provided the control power is supplied from a distinct, identified, and approved source. When installing VFD, several crucial factors require attention. Firstly, understand the specific requirements of the VFD. Different VFD models may have varying requirements for control power. Consult the manufacturer's documentation to ascertain the appropriate voltage, current, and other specifications for the control power supply. Secondly, ensure proper identification of the control power source. The NEC mandates that the control power source be clearly identified. This can be accomplished through labeling or other means. The intent is to prevent confusion and ensure that anyone working on the system is aware that the control power remains active even when the main disconnect is open. Thirdly, verify approval of the control power source. The NEC requires that the control power source be approved for use with the VFD. This implies that the power supply must meet specific safety standards and be suitable for the intended application. Check the VFD manufacturer's documentation for approved control power sources. Fourthly, consider using a control transformer. A control transformer can provide a convenient and safe way to supply control power to a VFD. The transformer steps down the voltage from the main power supply to the level required by the VFD control circuitry. This eliminates the need for a separate control power source and simplifies the wiring. Fifthly, implement proper grounding. Grounding is essential for electrical safety. Ensure that the VFD, the motor, and all associated equipment are properly grounded according to the NEC and manufacturer's instructions. This helps to prevent electrical shock hazards and ensures proper operation of the equipment. Sixthly, provide overcurrent protection. Overcurrent protection devices, such as fuses or circuit breakers, are necessary to protect the VFD and associated equipment from damage due to overloads or short circuits. Select overcurrent protection devices with appropriate ratings to handle the expected current flow. Seventhly, utilize proper wiring methods. Use appropriate wiring methods, such as conduit or cable, to connect the VFD to the power supply and the motor. Ensure that the wiring is properly sized to handle the current and voltage requirements. Follow the NEC and local electrical codes for wiring installation. Eighthly, conduct thorough testing. After installation, perform thorough testing to verify proper operation of the VFD and associated equipment. Check the voltage and current levels, motor speed, and other parameters to ensure they are within the specified ranges. Address any issues that are identified during testing. Ninthly, maintain accurate documentation. Keep accurate records of the VFD installation, including wiring diagrams, equipment specifications, and test results. This documentation will be valuable for troubleshooting and maintenance purposes. Tenthly, provide adequate training. Ensure that personnel who operate and maintain the VFD receive adequate training on its operation, maintenance, and safety procedures. This training will help to prevent accidents and ensure the VFD operates safely and efficiently. The NEC provides specific guidelines and requirements for electrical installations. Adhering to these regulations is crucial for ensuring safety and compliance. The NEC Article 430 covers motors, motor circuits, and controllers. This article provides detailed information on disconnecting means, overcurrent protection, motor control circuits, and other relevant aspects. The NEC Section 430.102 addresses the location of disconnecting means. It stipulates that a disconnecting means must be located within sight from the motor controller location. This enables personnel working on the controller to easily disconnect power to the equipment. The NEC Section 430.109 outlines the types of disconnecting means that are permitted for motor circuits. These include switches, circuit breakers, and other devices specifically designed for disconnecting motor loads. The NEC Section 430.110 provides requirements for the rating of disconnecting means. The disconnecting means must have an ampere rating not less than 115% of the full load current rating of the motor. This ensures that the disconnecting means can safely interrupt the motor current. The NEC Section 430.128 covers adjustable speed drive systems. This section provides requirements for disconnecting means, overcurrent protection, and other aspects specific to adjustable speed drives. The NEC Section 430.130 addresses control circuit disconnecting means. It requires that control circuits be provided with a disconnecting means that is readily accessible and capable of disconnecting all control circuit conductors. The NEC Article 440 pertains to air conditioning and refrigerating equipment. This article provides requirements for disconnecting means, overcurrent protection, and other aspects specific to air conditioning and refrigerating equipment. The NEC Article 670 covers industrial machinery. This article provides requirements for disconnecting means, overcurrent protection, and other aspects specific to industrial machinery. The NEC Section 110.3 provides general requirements for examination, installation, and use of equipment. It requires that equipment be installed and used in accordance with the manufacturer's instructions and that it be approved for the intended purpose. The NEC Section 110.12 addresses neat and workmanlike manner. It requires that electrical work be performed in a neat and workmanlike manner, ensuring that installations are safe and reliable. The NEC Section 110.14 provides requirements for electrical connections. It requires that connections be made in a manner that ensures a good electrical contact and that they are protected against corrosion. Variable frequency drives, or VFDs, are commonly employed to regulate the speed of alternating current, or AC, motors. They find extensive application across diverse industries, including manufacturing, HVAC, and water treatment. VFD afford numerous benefits, notably enhanced energy efficiency, precise motor control, and diminished mechanical stress on equipment. The fundamental principle of a VFD involves modulating the frequency and voltage supplied to the motor. By reducing the frequency, the motor speed decreases proportionally. The VFD achieves this by rectifying the incoming AC power into direct current, or DC power. Subsequently, it employs an inverter to convert the DC power back into AC power, but at the desired frequency and voltage. This process enables precise control over the motor's speed and torque. VFD also incorporates sophisticated control algorithms that optimize motor performance and protect the motor from overloads, short circuits, and other electrical faults. Additionally, VFD can communicate with other control systems, allowing for remote monitoring and control of the motor. When integrating VFD into electrical systems, meticulous consideration must be given to several critical factors. Firstly, proper sizing of the VFD is paramount. The VFD must be adequately sized to accommodate the motor's horsepower and current requirement. An undersized VFD may result in premature failure or inadequate motor performance. Secondly, harmonic distortion must be addressed. The VFD can generate harmonic currents that can distort the voltage waveform in the electrical system. Harmonic filters may be required to mitigate these effects and ensure that the electrical system operates within acceptable limits. Thirdly, grounding and bonding are crucial for electrical safety. The VFD, motor, and all associated equipment must be properly grounded and bonded to minimize the risk of electrical shock. Fourthly, surge protection is essential to protect the VFD from voltage transients. Surge protection devices should be installed at the VFD input to divert voltage surges away from the VFD. Fifthly, proper ventilation is necessary to prevent overheating. VFD generate heat during operation, so adequate ventilation must be provided to dissipate the heat and prevent the VFD from overheating. Sixthly, regular maintenance is crucial to ensure the long-term reliability of the VFD. This includes inspecting the VFD for loose connections, cleaning the VFD, and replacing any worn components. Seventhly, adherence to manufacturer's recommendations is vital. Always follow the manufacturer's recommendations for installation, operation, and maintenance of the VFD. This will help to ensure optimal performance and prevent premature failure. Eighthly, qualified personnel should be employed. Installation, maintenance, and repair of VFD should only be performed by qualified personnel who are familiar with the equipment and the associated electrical hazards. Ninthly, documentation is essential for future reference. Maintain accurate records of the VFD installation, including wiring diagrams, equipment specifications, and test results. This documentation will be valuable for troubleshooting and maintenance purposes. Tenthly, safety precautions must always be observed. Always follow all safety precautions when working with VFD, including disconnecting power before performing any maintenance or repair work. The NEC provides comprehensive guidelines and requirements for electrical installations. Adhering to these regulations is crucial for ensuring safety and compliance. When working with VFD, it's essential to understand the applicable NEC requirements and to implement best practices for installation, operation, and maintenance. This will help to ensure that the VFD operates safely and reliably for many years to come.